Okay, so we're going to start our last two levels of design, starting with life. And everyone knows this is the one that gets talked about the most in our culture. You'll hear origin to life, you'll hear evolution, you'll hear a lot of the words that, they basically prove that they can make life and all these type of things. This is effectively what Darwin thought the cell looked like. This is all he had to work with. He thought the cell was basically a bag of cytoplasm and a nucleus. You could, even in his day, you could see with microscopes cells doing mitosis, which is the splitting. They could even see the nucleus and the chromosomes inside. But he believed it was basically just a sack of, and he has this quote in Origin of the Species. This is his famous book, and he says, "If it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down." So that's what he said about his own theory. This is a very simple model of a normal cell in our body. And you can tell it's kind of complex. I won't go into the details, but if you were to remove any one of those components from this living cell, the cell would either die immediately or it wouldn't be viable, which means it would starve to death. There's no component of a human cell that you can remove and still maintain viability as far as a whole component. So there's no pathway to modified single steps. You have to have everything or nothing. And that's just the big, our animal cells, so cells like in our body. And, I look at this and what we know from science. And when we do the science session in a couple of weeks, I'm going to show some, they have done animations of what goes on in the cell based on what we know. They can see it in an electron microscope, but what they've done is done animations to try to show it to high school kids and college kids. This is right out of science classes, so it's not Christian. And when you see it, if you don't see God, you're just hardened to the complexity, because it's just amazing how these things inside our cells move around. But they don't move around randomly. They move around with purpose. There are certain proteins that attach themselves to the chromosomes when a certain thing needs to be made, because there's something else that they've sent someplace else in the body. How our body knows how to do these things, we simply don't know. Physiology and anatomy and microbiology give us some insight on what it does, but why and how it does is just amazing. So very complex. So the first thing you think, okay, so that's the animal cells. Those are complex, right? Well, let's look at a plant cell. A plant cell, frankly, plant cells are more complex than animal cells. We have bones and muscles. The cell wall is amazing. Without the cell wall, there's no structure to a plant. All plants would collapse. So you can't have that evolve into playing. And if there wasn't chloroplast, the plant couldn't get any energy. It has to have chloroplast. But how did chloroplast come about? I mean, that's how it takes sun and then makes energy. And I think in terms of high school biology, this is what I learned in high school biology. Consumers and producers. A consumer is something that consumes, and a producer is something that produces. So which came first in the evolutionary model? Tough question. There's not an answer. Photosynthesis is the common way that producers make energy. Now there are other methods. There's one called chemosynthesis, which is, it's only found in the anthropic region of the sea, which is way at the bottom when there's no sunlight. And it only happens around volcanic vents. But there's no relation to what there is on the surface to what's happening underwater. And the evolutionists try to ignore the chemosynthesis because it really makes it complicated to imagine how any living organism would start on the surface and never get there and then change its method of generating energy from nothing. So the very fact that there are alternatives to photosynthesis make it even more complex. That how do we do this? What's the perfect balance? Can any of these components be derived step by step? Because if I'm a producer, okay, so I can produce my own energy. So how did I become a cell and then become a producer? Which came first, the producing or the cell? Well, you can't have a producer if there's not already a cell. So it's this circular logic. If it's okay, what is the component that could start that would result in eventually getting to life? And I look at this photosynthesis model, and this is just out of a biology textbook, and it's incredibly amazing is what it is, that sunlight comes down and the plant absorbs carbon dioxide from the air and some minerals from the ground, and then generates oxygen and sugars that you and I can actually eat. I mean, it's amazing. The cycle of life and how chloroplast works is just, and it's incredibly complex. And like I said, come back for when we do the science versus naturalism, a couple of sessions, and I'll show you some animations of the chloroplast, which will blow you away if you've never seen it. So most naturalists would say, well, these are complex organisms. Obviously, this is not what we started with in their model, right? So like, okay, let's talk about something simpler. Well, one of the simplest single-cell organisms is the amoeba. And that's what an amoeba looks like under a microscope. And the Darwin level of scientist, when he came up with this theory, it looked like this. It's just a blob. You see the nucleus in the middle. It looked like there's no complexity to it at all. So this is their link. Well, we know now that an amoeba is pretty complex. It has a lot of components inside of it that without any one of the components, it fails to survive. I mean, how would it take in food particles? And again, where's the food particles coming from for the simple organism? Because there has to be a producer someplace to make the food particle. These are organic compounds that have to be made inside living cells. They don't happen outside of living cells. And that's kind of one of the secrets that people don't ever tell you about evolution is the chemistry that happens inside a living cell can only happen inside a living cell. It can't be reproduced outside of a living organism because of the way the chemistry works. It has to branch these huge, long molecules have to have shape. Shape is what gives life its specificity. And without that shape, it just doesn't work. And when we do it outside of the cell, for some reason, we can't reproduce the shapes. We just cannot. So, okay, the evolution is like, okay, so that's a single cell animal type creature, right? An amoeba. What's simpler than an amoeba? Can you think of anything? What about bacteria? So some people say, well, bacteria was the first form of life. And this is E. coli. I think this is E. coli. Is that E. coli? Yeah, it's E. coli. It's in your stomach right now, E. coli, right? And it looks pretty, not very, it just looks like a big blob. Yeah, Cheetos, right? And modern science has changed the way we look at bacteria, because up until the last, maybe 40 years, this is what we knew of bacteria. This is what that bacteria really looks like. It has, a nucleoid inside, it's got cytoplasm, but the amazing thing is what's on the outside of the bacteria. And we'll just look at the flagella for a second. That's how the bacteria moves around, right? Is this amazing device. This is what it looks like.
Is that
It's made up of 29 very unique proteins that have specific features and characteristics. It's just like a modern rotary motor. We didn't discover rotary motors until, the 1960s or 70s, I think it was. And every bacteria had already had one of these from God's creation. We're just catching up. If you remove any one of those proteins, the device doesn't work. And they've tried. E. coli is one of the most tested bacteria. They've been trying to induce mutations in E. coli bacteria since, you probably know better than I do, Annie, this is more of a medical thing, but it's like since the 50s. I mean, millions and millions and millions of mutations have been forced on E. coli, and what we discovered is mutations always result in less information, never more information. And mutations result in either death of the subject or loss of viability, which means it can't reproduce. So evolution says those mutations should lead us to new information and new function, but despite a very focused effort that has gone on for more than 50 years, they have failed to achieve even one slightly modification that would be considered new information. It's always been less. And I think the complexity of the flagella is just amazing. You look at, it looks like a rotary motor if you look at the bits and pieces. Yet this is a biological system and one of the simplest organisms on Earth. And the organism is, we think of it as simple. It's a simple one-cell organism, but look at the complexity of just one component of that bacteria. And in fact, it has several different components that have that kind of complexity. It has something called an injectosome, which is how it injects into its whatever it's going to symbiotically work off of. And there are several components on something as simple as an E. coli bacteria that have multiple parts. I mean, dozens of parts that are necessary or it doesn't work. And in fact, any one of those proteins was not there, the bacteria itself would either not reproduce or it would die because it couldn't feed itself. And so where is the stepwise evolution that we always hear about? Any component is missing, it just simply doesn't work. Not to mention, you can't see a progression of components. You can't see where, oh, this could potentially have turned into that. They kind of look the same in this picture, but what you see is that actual proteins are not the same. They look similar, but they have totally different functions. And they've tried to do substitution, on the molecular level to see if they could muck with these components. It always fails. It always either kills the bacteria or it makes the device that they're trying to muck around with not work. So again, this is Darwin's own words coming back to haunt him. These cannot be broken down into simpler parts. We cannot imagine any stepwise evolution that would lead to more order. Everything that we do always points toward less order. And so again, it points toward a designer. I mean, I look at the rotary motor on the flagella and I'm like, accidentally this came into being. How? I mean, how? I mean, this is a model that humans came up with for their own machinery. And if we saw the machine if you run across an engine in the middle of the forest, would you think it just came into being because it sat there for 1 million years? Or do you think someone actually built it and put it there? Yet we see this on the microscopic level where we can't even do this, and we think that it happened randomly by chance. That's the frustration, I think, that Christians have with science is you talk nonsense because you think it sounds better than the concept of God, when the complexity is far beyond our ability to design and make, yet we think it's randomness. Go ahead, Jude.
Well, why is the Christian Scientist not point this out to those people that believe that it just was just like that? And go back to Darwin. This is what Darwin said. So he's debunked. So why can't we?
The Discovery Institute talks about this a little bit, but they are attacked by the scientific community. Look at James Tour here at Rice University. He came out against Origin of Life, but they're scared because their livelihoods are at risk, and most people are the funding. Well, James Tour, I don't know if you know him. He's here at Rice, and he's been
The problem
out.
with that is you don't trust God.
Well, he's kind of my,
Protect you or take care of you.
I would call James Tour a hero because of the last maybe, was it been 5 years he's been in this fight?
10.
He was asked to comment on an origin of life paper because he's an organic chemist. That's what he does. And he looked at it and said, well, this is all crap. He's a Jewish Christian, okay? So he just says what's on his heart, right? Boom. He says, this is all crap, and pointed all the ways it was total crap what they were saying. And the establishment went after him, personally trying to
Actually,
discredit
even
him.
as that, not as hard as that. He just said that this needs more scientific testing because it's not clear.
Well, what they were presenting was not,
It's more.
it wasn't
Yes,
true. How's that?
It's not as what you guys are saying. It needs more study.
Yeah, he never say that it couldn't be discovered. He says it's possible that humans could discover the origins of life. It's possible. I say it's impossible. He says it's possible because he's a research scientist, and he says nothing can be said to be impossible. You can only say that we aren't there yet. But they attacked him. They tried to discredit him. He had trouble getting funding. He had groups tell him, don't bother even putting proposals in. You're going to be defunded. He's the head of the National Science Foundation today, and he controls the purse strings. That's how God works.
It just happened.
It just happened. This is very recent. And he'll be very fair because he's a Christian and he believes God's approach is his approach. But so not very many stand up because they think they're going to get canceled in our society. A lot know it. I mean, the Discovery Institute sometimes comes out with things and then they get hammered by
That's true. Behe got hammered.
Behe, Stephen Meyer, J.P. Moreland. They're all part of the Discovery. Well, Behe he always tries to explain the complexity of things and how it can only come from a designer. And